This is Fun with Electronics Project 5 Part 2, where we ask AI to generate an interfacing circuit, which basically acts kind of like of this like overall driver that turns each of the LED delay circuits on. And basically, we're just asking AI to generate kind of this Knight Rider like show using its own interface circuit. So something kind of like the NPN PNP configuration from last video. So right here, this is the NPN PNP, and as you can see, the NPN transistors were taken off to design the AI circuit. So yeah, so basically, um, so I did ask AI. Let's head over there. Let's start from the beginning, okay? So here I asked AI ChatGPT to create an interfacing circuit, kind of like the NPN PNP configuration, like the one I showed. And yeah, so basically, since ChatGPT remembers one of my previous conversations, so it remembers what project uh, we're talking about here. So here it gives a recommended solution using another NPN PNP configuration, but I wanted something different. And here it gives the information of that circuit, right? And then since I wanted something different, I asked ChatGPT to create another type of circuit, but with the same results, giving the same result. So here I gave a second option with a MOSFET, but since I don't have any MOSFETs available, um, I wanted something that's more like something that's more like simple, more something that's more simpler. That's yeah. So here I told ChatGPT that I don't have any MOSFETs. And here it gave a third option, basically, which was just using an NPN transistor as a switch, basically. Yep. So basically, what this circuit provides is just a switch that connects basically the whole circuit with ground, basically turning the LED circuit on. So yeah. So here, what it says that if the that if the output of the counter circuit goes high, then the base voltage through the transistor goes high. Then turning on the transistor, which makes the current flow from 9 volts to the through the LED circuit, through the transistor, through ground, which activates the LED circuit. And if the output is low, then there's no base current. Transistor turns off, and so then the LED circuit turns off. So yeah, here it gives some requirements, some values, and so yeah, so it just gives some final takeaways, some insights. So yeah, so basically I followed this circuit over here, and here's my drawn version of it. Sorry, let me go to my laptop here real quick. So here we have my overall hand drawn circuit over here. So yeah, so as you can see, basically, here I have 9 volts connected to the LED delay circuit from Project 4, which is connected to the collector of the NPN transistor, which its emitter is connected to ground. So yeah, so that's basically how it's going to be connected, basically, and we have a 2.2 kilo ohms as the base uh, resistance, just to avoid any damage to the transistor, right? So yeah, so nothing too complicated, and yeah, and we'll test the circuit and see if AI was successful. Then if it is, then we'll move on um, to 10 hertz, because right now I'm testing it with a clock frequency of 1 hertz from the 555 timer circuit. So yeah, so the battery is connected from 9 volts, and now we'll turn off the 6 volts that connects to the 555 timer circuit and the counter circuit. Let's turn this on. All right, it's on. And as you can see, it's working. As you can see, look, pretty cool, huh? So this basically is giving a simpler version instead of something complicated like the NPN PNP configuration, which is actually nice, actually, like because you don't have to like find more components, testing each transistor, like seeing if it's a PNP or NPN. You'll know that it's an NPN. So yeah, so that's nice. So now we're gonna test the circuit with 10 hertz of clock frequency, and yeah. All right, so here I changed RB and C, so that the 555 timer is configured to 10 hertz of clock frequency. So it's tuned now. So now let's turn the circuit and see its behavior. Oh wow, okay. So as you can see, basically, it's acting like Ryan circuit, basically. Yeah, it's showing the same amount of delay, but overall, you can still barely see where the LED is the most brightest, so you could follow it basically. So yeah. All right, let's turn it off. As you can see, still goes, and it turns off. Yep. So yeah. So yeah. Here we have basically the the transistors, the NPNs on the upper half of this breadboard. So basically that the interface circuit, both the interface circuit and the LED circuit, the delay circuit were condensed into this one breadboard, since the interfacing circuit that was given by AI is basically just using one transistor. Then it basically, I figured it was a good idea to condense it all into one breadboard, just for just to compact it all into just one system, basically into one place. It's just a habit of mine. So yeah, as you can see, that here we have the NPN transistor, and yeah, we have 6 of those in the upper part of the breadboard, and then the lower part is basically the LED delay circuits, basically. So yes, but still, it works, basically. It works. So now let's replace RB, which is this transistor in the middle, basically in the middle of the this first breadboard, and replace it with an LDR, then with a potentiometer, and see its behavior. All right, so now we have the RB replaced with an LDR. So now let's turn on the circuit. All right, and let's shine the lamp at the LDR, see its behavior. All right, looks like it had the speed has increased a little bit It's barely noticeable, barely, a little bit. Then if I shine it away, it has gotten a bit slower. If I shine it, if I if I face the lamp towards the LDR, then the speed increased a little bit. I don't know if you guys see it, but I see a little bit. I see a little bit of difference of in in speed. All right. So now let's replace the LDR with the potentiometer that we have right here and see how it affects the LED. So basically, as you guys might have seen in the previous videos, the potentiometer won't give that much of a difference in basically in speed, since, like I said before, sorry, not the LDR, but the potentiometer gives basically a small range of resistance, since its maximum it's about 10 kiloohms, and the LDR's max is, I think it's about 150 kiloohms, which is actually higher than the potentiometer. So yeah, so I won't be surprised if with the potentiometer the speed doesn't change. All right. All right, now we have the potentiometer connected to the 555 timer. And now that the LDRs is connected now and everything is in order, now we can turn on the power supply. Still at 5 volts, as you can see. And the circuit's still functional. All right, so now let's see what happens when we turn the knob clockwise. As you can see, no significant change in speed. Turning it counterclockwise. All right. All right. Turning it clockwise again. Still no significant change. Well, that's expected, since the range the potentiometer provides is very little. Right now I'm turning it counterclockwise and counterclockwise. Yeah, no significant change in speed. So yeah, so overall, basically, the circuit was successful. The Especially the interfacing circuit, as you can see, that consists of one NPN transistor connected from 9 volts to the LED circuit connected to ground. Basically, that was enough to drive the LED, to drive the to drive the relay circuit. Basically, it was enough. So yeah, so AI was successful overall in creating this type of circuit, and yeah, so pretty cool, nice.